In this video, I'll show you how to integrate inverse kinematics to blend the motion of the location of an object with an actual animation. So the bot we've got here is going to bend over and pick up this muffin, ham and egg muffin that's on the floor here. So the location of the particular muffin will dictate where the right hand is going to be. Now you can get this project if you download the starter and open up the pick up burger scene, which will look like this. Right, so to begin with, let's just examine what we've got. We've got our Y-bot in the scene. He's got a bot controller added to him. If we have a look at that bot controller, we can see here that there's a happy idle animation and then a lifting animation. And the transition from happy idle to lifting has a condition on it, which is pickup. And we've turned off the has exit time. And so we'll code that pickup to occur when we hit the space bar. Notice also that the base layer has the inverse kinematics turned on as well so that we can influence the animation. Right, so let's begin by creating our pickup script. So over in project, go create C# script and call it pickup and attach that script to the bot and then double click to open it up. Okay, so we're going to replace the middle part of this function with this code here. And this is pretty similar to the code that we first created when we looked at inverse kinematics, moving the hand around with the sphere. So this one here is the same. It's got a target location, which we will set to be the muffin. And then we use the on animator IK to set the IK position for the right hand and also the weight. You'll notice the weight is set to 1, so it's going to fully blend in the hand's location, looking at the target or pointing at the target. And the set trigger for pickup happens when the space bar is selected. So save that, then go back to Unity, select the bot and find the script where it's attached and you've got the exposed target. This is where we grab the ham egg object and drag and drop it onto there to be our target for that right hand. Right, so at this point, if we run it, what you'll notice immediately is look at the right hand. Okay, so it's gone down to look at, or I should say point at the muffin that's on the ground. Now, we don't want it to actually be doing that while we're in the idle state. Now, what I've also noticed right now is that we don't have looping turned on that idle. So let's just fix that. Let's find the animation, which will be inside this YBot pickup folder. Go to the happy idle animation, over to animations, and let's go down and turn on the loop time for it, and then click apply. Okay, so now when we play it, he should be in the happy idle state for quite a while. Now, if at this point, we just select the Y-bot and go down to the script and untick the box next to it, and this will make it not run, and so you can see what the idle animation is meant to look like without that arm pointing. Okay, so the arm's quite free, jiggling around. Now if we click the script back on, because of those IK commands, the hand goes zounk and straight down to wherever this is. Now if we go into the scene and actually grab hold of that burger, select it in the hierarchy while you're playing and move it around, you'll see it has an influence, which is not what we want. Okay, we want the bot to be able to bend over and pick up that burger. So let's just try it anyway while the hand's still pointing at it. If we press the space bar, we'll bend over to the location of where that burger is and then has a look at it before going back into idle. So if we move the burger out to here and then we press space bar, you'll see that he reaches in that particular direction for it. So it is influencing the joint. It's just that we need to control when that's going to happen for us rather than all the time. So we can do that by manipulating that weight value that's used in the code by having the animation actually control what it is between 0 and 1. So when it's 0, it's never going to blend that movement of pointing at the burger into the animation, but when it's 1, it will be fully integrated. Let's do this with a parameter. Go to the animator window for our animation that's on our bot, and in there we want to add a float, and let's call that IK pickup. Now, I've spelt it with a capital I, capital K, capital P, and then small letters afterwards. It's very important how this is spelt because it needs to be referenced in several places within the actual project. Now, it's going to initially be set to 1, which means it's not going to influence the picking up of the burger whatsoever. Now, back in the code, we can then use this value here as the weight value. So let's just open up that code again, and the line you need to add is just this line here. So that instead of weight staying the value of 1 that we initially set it to up here, it actually uses the value that's inside IK pickup. So this has to be spelt exactly the same as this up here. Now at this moment, this is 0 and it's always 0. So if you just save that and switch back to Unity, press play, you'll notice in this idle state now, because that IK pickup is 0, weight is 0, and the arm is not trying to go for this burger. And in fact, if I go back to the scene and just grab hold of that burger, I'm just going to move it out here a little bit. Now when we press space to do a pickup, you can see it doesn't even go for this burger because that weight is still 0, so it's not influencing how he's trying to pick it up whatsoever. All right, so to get the IK pickup value here to change with our animation, we're going to add an animation value for IK pickup in the actual source of the animation. Right, so let's go to the source of that pickup animation, which is this bot lifting animation, okay, which is inside that YBot pickup folder. Over in animations in the inspector for this particular animation, right at the bottom underneath all of these settings for root positions and that is a little thing that says curves. If you drop that down, you can now add a curve, and a curve allows you to, I guess, change a value over the length of the actual animation. So to set a float that just changes with the animation. What you put in this value here where we added the curve is the actual IK pickup. Make sure you spell it exactly the same capitalization as this. So this value here actually controls what's going on over here. So we want this value of IK pickup to change between 0 and 1 and back to 0 again. So we want it to oscillate during that animation so that it has no influence at the beginning. In the middle of the animation, when the bot's fully bent over picking up the burger, it's going to be a 1, so it's actually right on that burger. And then when we come up to a standing position from picking up, we want it to be back to 0. So we can add a curve, and to do that, just click on this little graph here, which shows you the keyframes for the value of IK pickup over the length of that animation. The curve we will add in the middle here. So just right click on that and go add key. Then this key value here we want to set to 1 so that it oscillates between 0, 1 and comes back to 0 again. Now you might notice that on this graph here that the first value here is 0.05. So 1 is an awful way up there to actually pick up and drag this keyframe all the way up to 1. So rather than do that, you can just drag it up a little bit, close that, then go back over into the inspector and you'll now see that you've got a nice little curve going on here. Now, we can actually use these forward and back buttons to move through the keyframes, and you'll see a very slim red line come up on the curve that shows you where you are. So in the first keyframe, you're at 0. In the middle, you're at 0.47, and in the last keyframe you're back to 0 again. Now we want to go to the middle and just set this to 1. Now that just saves us trying to drag that curve up. If we go back to here now, you'll see that the scaling has changed and you can see that full curve at 1. All right, so now when we play, just keep your eye on this value over here, because you will see this go up to 1 and then come back down again as this animation for lifting occurs. And as it does, it changes the weight of the influence on the IK, and the hand should go for the burger. So let's press play. Oh, and apply those settings, very important. Okay, so no influence, press space, influence, picked it up. Notice there at the end of the animation, there's still a fair bit of influence, possibly that we don't want, while this value here is still going down to 0. So that the actual pickup is not right in the center of that pickup animation. It's sort of more towards the beginning of it. So we can modify that if we find our animation for lifting and go back to our curve. And just grab that keyframe and maybe drag it back just maybe there. And then just, let's have a look. So notice that arm sort of comes back out again. There's not so much influence. And you could even get a little bit cheekier and actually have it so it's not at 0 there. Add another keyframe. Maybe here. And bring that influence right back down to 0, sort of much quicker. I always forget to hit apply. Okay, let's go now. Picking it up, and that's heaps better. So that shoulder joint doesn't look so distorted when it picks it up. Okay, so that's changing this IK pickup value with the curve. Very handy if you want to change values like that. And the last thing that we really need to do is make sure that when he does pick up the burger, that the burger stays stuck to his hand. Attaching the burger to the hand joint is a matter of knowing where the hand joint is and then setting the parent transform for the burger to the hand joint. So in the code, let's just go here. What I've added that you can add to is there's a public transform for hand at the top here. And later down here in the animator IK, is I'm saying if the weight, so this is the weight of that IK for picking up the animation, is greater than 0.8. So remember, it goes between 0 and 1. So at some point it's going to be greater than 0.8, which is when you're at the height of pointing at the burger. So I'm going to use that. Now you could change this if you want it to attach to the hand quicker. But anyway, if it's greater than 0.8, then we're saying that the target, remember the target was the burger that comes in, that the parent is going to be set to the hand. So the hand, the transform of the hand, will be the parent. So all of the transforms that go on with the hand, the rotations and the positions, the burger will get also. Right, so if you save that code and switch back into Unity, let's go to the bot. We now have the hand, which will be exposed. Now, I've already set this up, but you can do this. We want to grab hold of the right hand's transform and drag and drop it into there. So you'll find that under YBot, expand out the hierarchy. So we're going to the spine, we're going to find the right shoulder and then continue down the right arm to find the right hand, which is this one here. So we get that one and drag and drop it into the hand position. So now the burger will attach itself to the hand. So let's just try that out. So let's bend over and pick up the burger. Now at 0.8, let's just pause that so we can have a quick look at what's happening. You'll see that the burger is in fact moving. Something has happened to the burger. if you have a look through your hierarchy for your bot, if you go down to the hand, this is in this hierarchy tab, you'll actually see the burger is now attached to the hand, but it's attached at a very strange position because of the way that Unity takes the existing position of the burger, uses that, and then applies the actual transform of the right hand as well. So if you click on the burger while you're still in play mode and it's attached to the hand, if you go over and look at the transform component, you'll see some pretty wild looking values going on in here. Now at this point, if we actually set this to 0, 0, 0, the burger will snap back to that hand joint and make the rotation 0, 0, 0. And now it's neatly at 0, 0, 0 attached to that hand joint. Probably not the way you want to be looking at the burger. So at this point is when we actually start to manipulate the location of this burger with respect to the hand while it's still joined, and take notice of the values we get in the transform. Right, so I'm going to move this burger around. Maybe rotate it a little bit. Move it. Looks like it might need a resize also, but you can do that right at the beginning. So that's a bit better. He's actually sort of holding it. Could just move it out a little bit so the fingers show through at the edge. That's not too bad. So at this point, we want to then note down the position and the scaling values for this burger. Now, if you actually have a number in this box that has a little E on the end, that's pretty much the same as saying 0. So let's just put 0 in there for the Z. What I like to do at this point here now is just to get rid of all those decimal places, because it doesn't need to be that accurate. So the Y is minus 1.3. And this X rotation is 331. Okay, now you'll see that these will just snap back to whatever. That's 358, which is almost 0 degrees essentially. So you've got only a rotation in the X and then small values in the Y position. Okay, so note these values down and then we will come back and put them into the script. So in the script, just open that up and you'll find I've already added those in here. Now these values are going to be specific to the actual situation that you're in, your model, size, positions of its extremities and all of those sorts of things. So you will have to experiment as far as pausing the animation while it's actually playing and then positioning stuff by hand and grabbing a hold of the transform values. Alright, so what's changed now is inside this if for grabbing hold of the actual burger, just after we've parented it to the hand joint, there's 2 lines of code that you'll need to add. You need to modify the position of the burger and also the rotation of the burger. Now that's not the burger's position in space in the world, it's the position relative to the hand. Okay, so we need to use a local position and a local rotation value, and we set the local position to the values that we got out of the inspector in the transform component, and we set the local rotation to the X, Y, and Z rotations that were in the transforms rotation as well. Now the code that you need to do the rotation is actually Quaternion.Euler, which will convert an X, Y, and a Z rotation into the right format that's needed by the transforms rotation. And the position is just a vector 3. All right, so once you've done that, if you save that, go back to Unity and run, and then go to pick up the burger. Now you'll notice that that burger gets picked up pretty quickly, like it snaps to the hand way too quickly. So you can modify that in your script. Instead of saying 0.8, we might want to say 0.8. 0.95 for our weight. Yeah, that's a bit better. So it doesn't actually snap to the hand till he's got his hand on the burger. And that looks good.